So far, all the limits that we've done, we've just written down an actual value, or we've said the limits do not exist. Okay? We're going to talk specifically about infinite limits here today. This is kind of our last idea on limits. I sent you this link. This link has some very good examples, very good notes. I'm going to kind of summarize it for you here today. I think it'll be enough to get you to where you can feel comfortable with the practice. Okay, but let me kind of give you a little bit of an idea. All right, I'll kind of read this here for a second. In this section, we will take a look at limits whose value is infinity or minus infinity, negative infinity. These kind of limits will show up fairly regularly in the later sections, and so you'll need to be able to be familiar when you see them. Okay? The first thing we need to do is to define what we mean when we say a limit has a value of infinity or negative infinity. And this definition that you see right here, I kind of summarized over here. All right? We can say that the limit of a function is equal to infinity as x approaches some a value, as long as that function is increasing infinitely as we approach a from both sides. Okay? So visually, what that would look like then, if here's my a value, as I approach a from the right, my graph is approaching positive infinity, and as I approach a from the left, it's also approaching. And what we'll get into then is, yes, there would be an asymptote at a. Okay. In the past, I've just told you to write does not exist because we've just been working with finite limits. Okay, limits that have an actual value. But specifically, we're going to talk about infinite limits here. Okay, so that answer of does not exist, now you're going to be able to put the limit is infinity or the limit is negative infinity. Okay, but it's kind of a special set of limits on their own. It's still not a finite value. Okay, keep that in mind. But you can only say that the limit of a function is equal to infinity if they are both approaching positive infinity from the left and the right. Okay, and that's what I kind of wrote here. If you just want to use a picture instead of writing this, that's probably fine. But the limit of the function is infinity as x approaches a, if f of x is increasing infinitely as we approach a from the left and the right. The opposite of that is also true. We could say the limit of some function is equal to negative infinity as long as from both sides we're heading down to negative infinity. I think you guys could draw your own picture for that if you needed to. Just have the graph be headed downhill. We can still do one-sided limits. Okay? Let's go with the function that everybody knows. F of x equals 1 over x. What is the limit of this function as I approach 0 from the right? I'll just ask you specifically for a one-sided limit right here. What is the limit of this function as I approach 0 from the right? Need a quick refresher on the graph?
Positive infinity.
Doesn't this graph look like this here? And I approach 0 from the right. What is that graph doing? Increasing infinitely, right? So the limit of this function as I approach 0 from the right is positive infinity. What is the limit of this function as I approach 0 from the left? Negative infinity. What is the limit of this function as x approaches 0?
Does not exist.
Why?
Because it's approaching to it.
it's not approaching, they're not both doing the same, right? Which, based on my definitions here, for an answer to be this, I need to be going towards positive infinity from the left and right, or negative from the left and right. Yes?
Back to like last unit,
Yeah.
like so, even though like two values are approaching and there's a hole, it still count, like, that's like where, like the limit would be.
Mm-hmm.
What happens if like there's just a whole bunch of holes? Like, what happens if you have like holes on holes on holes? Like,
Holes on holes on holes. Never heard that said like that.
Because there's probably not values close enough to that x value from the left and the right, because there's a bunch of holes on one side, basically.
Yeah.
Oh, that's great.
I don't think we could find the limit, alright, Dakota?
Okay.
I know what you're saying.
Yeah.
Does not exist because one-sided limits don't match. Right? So the limit of that function as x approaches 0 does not exist because our one-sided limits do not match.
Oh, yeah, that was funny. Yeah, no, you know, straight face.
Okay? Time to finish writing that. Those of you that are doing that. I'm going to change my function here. Okay? Go 6 over x squared. F of x equals 6 over x squared. You have graphing calculators, and you could enter this function into your graphing calculator. Please be certain that you do this, y equals 6 divided by parentheses x squared. Okay? That way it doesn't divide by x first and then square it. Okay? But I still think we can figure this out without a graphing calculator. Let's think about this. As my x values get really, really large, what's 6 divided by a really large number squared? Essentially going to equal really small positive, right? So I know as I move this way on the graph, I'm going to be approaching 0. As I move back this way towards 0, I know I can't divide by 0, but if I take 6 divided by a really tiny positive number, so like 6 divided by 0.000001, what sort of number do I get? A really large number. Because 0.0001 squared would be just an even tinier decimal, right? And 6 divided by even a tinier decimal is going to be huge. So the graph on this side looks like this. Similar to 1 over x. Okay? How about on the negatives?
It'd be like the same thing with flip.
Same thing, but reflected over the...
You just square it down the bottom, so.
So will it be down here or up here?
Oh, be up there.
It'll be up top. Because even if I take a negative number and I square it, it becomes positive. And 6 divided by a huge positive would still be approaching or get really close to 0, right? So it would look like this. Again, if you don't do that in your head, that's totally fine. If you want to use your graphing calculator to get a picture of that graph, go for it. Okay? But for right now, what I'm going to say on these infinite limits ones, go ahead and use your calculator or use the graphs of them to help you determine what the limits are going to be. So what's the limit of this function as x approaches 0 from the right? As I approach from the right, positive infinity. From the left, positive infinity. And how about just as x approaches 0, period? Why can I put infinity?
Because it's approaching, they're both approaching infinity.
Okay, both from the right and the left are increasing infinitely. Okay? Alright, so everybody's okay with this?
Yup.
Okay? Vertical asymptotes. You guys know vertical asymptotes occur at the x values that only make the denominator equal 0, right? Okay, which is good. I'm going to give you kind of the calculus definition here. F of x has a vertical asymptote at x equals a if the limit of f of x as x approaches a from the right equals positive or negative infinity, or the limit of the function as x approaches a from the left equals positive or negative infinity, or the limit of the function as just x approaches a period equals positive or negative infinity.
Okay.
It doesn't need to satisfy all three of them. Okay? As long as it satisfies one of those, you know that function has a vertical asymptote at that given x value.
Couldn't we just written it like the limit of f of x equals plus or minus infinity as x approaches plus or minus? Okay. Just short it down. Plus or minus, that limit changes.
I mean, to a degree, yes, but it almost looks like it has to be from both sides then, I guess, a little bit. If you're thinking of putting a plus minus right here, what you're saying?
Well, it must be specifically inside. It might be the same thing.
You never see that notation where they put plus minus right there, but I understand what you're saying. You won't see that though. Okay. All right. I think. I believe you have enough. Oh, one more thing. Is that what I do? Let's say the limit. Let's say the limit of f of x is infinity as x approaches c, and let's say the limit of another function as x approaches c is actually a value. Okay?
This is dumb.
Alright, guys. What do you think that would be?
What's the GFX? What's that like?
Some number. Minus in there too, put it on that. So the limit of some function as x approaches c is positive infinity. Okay? And then we have some other function, g of x, And the limit of that function as x approaches c actually equals a number, say 7, 2, -4, whatever. It equals some finite value. Okay? What do you think the limit of f of x plus or minus, doesn't matter which one it would be, the answer is going to be the same, g of x would equal as x approaches c?
Infinity.
Why?
Because infinity goes on forever and it doesn't matter if you add or minus it, I guess.
Infinity plus or minus some constant is still infinity. That constant has such little impact on it, we can say this is still infinity. Okay? Thoughts on that idea? Because infinity plus or minus 3 is still infinity.
What does the L mean?
It's some number. Yeah, this is saying that g actually has a finite limit. Okay? Let me give you an example. Let's say f of x is 1 over x squared, and g of x is
3.
I'll just even go 3. I'll just stop there. Okay? The limit of this function as x approaches 0 is infinity, because that'd be a function kind of like 6 over x squared we did a second ago. Okay, that one would be infinity. So the limit of this function is infinity. What's the limit of this function? 3. So if I were going to add those two limits together, I'd have infinity plus or minus 3, which is still just infinity. So basically infinity outweighs any limits is what this comes down to. Okay? How about the limit as x approaches c of f of x times g of x? Thoughts? Which would still be what though? Infinity. It'll be infinity if L is what? Positive. Infinity times 4, still infinity. Infinity times 8 is still infinity. So if L is greater than 0, right? What if L was less than 0? It would be negative infinity. Because infinity times -5 would be a negative infinity. Okay?
If it was 0, it would just be 0.
If it equals 0, it would be 0. And then one more. What would the limit as x approaches c of g of x divided by f of x equal?
Really,
One over
small
infinity.
number divided by
1 over infinity, which is essentially 0. This would be 0. Because you basically have L, so some constant, alright, divided by a huge number.
What if those two were flipped? Small
Okay.
number of x divided by
Still be infinity. Yep. Doesn't matter if this is positive or negative, L. Would it still be essentially 0?
yeah.
Because
Either way, it's
12 divided by positive infinity is almost 0. It's a positive number, but it's almost 0, right? Negative 12 divided by 7 quadrillion is a negative number, but it's really, really, really close to 0. It's a very tiny negative number. So either way, you're going to get 0. Okay? So, stretching your brain here a little bit. Let's do page 88, 37 to 43 odd. Page 88, 37 to 43 odd. We'll take a few moments to get this done and then I'll teach the next one.